Hi guys, welcome back. I'm Loganathan, and in this video, I'll share you the knowledge of how to do multiple docking using pirates. And hope you guys know the basic concept of docking, where we have to dock a ligand to the protein of our interest, and we will get different poses. If we do single docking for 100 molecules, like you have a set of list of compounds, ligands, which we have to do, we have to dock it to the same receptor to get your lead. It would take more time than the multiple docking, and it is a tedious work too. So in multiple docking, we will dock the n number of ligands to the particular protein. Each ligand will give different binding poses, like different binding poses as the single molecular docking. This will help you to screen the large set of molecules to your lead, so that you can do high precise docking using any other software. So without further ado, let's get into the video. Then I have separated the video into three parts. In first part, we will prepare the ligand and we will collect the data for the ligand using some of the codes I have created. And then in the second part, we will do multiple docking, followed by the third part, in which we will analyze the results generated from the multiple docking. Okay, let's move on into the first part. So for molecular docking, we have two components like ligands and then our protein of interest. So since we have n number of ligands, like 10 ligand, 10 to 20 or whatever, we have multiple ligands, so we can't download everything one by one. Okay, it takes, yeah, we can download, but it takes a lot of time. So I have created set of codes which will help to download the list of compounds in which we have in the Excel files. Don't worry, you can access these codes through GitHub or something. Somewhere I will just share you the link. So but before that, I'll just show you the codes. Yeah, here it is. Here we have, these are the codes which I generated for multiple docking, in which we will use only this PDB to PDBQT till Excel to Chem. I'll show you how these codes work on the next step. So to download the multiple structures, structures of the multiple ligands, you need to you need to have the name of the ligands. So I just collected the name of my ligands in Excel sheet. I'll just show you. Yeah. So this is my Excel sheet where I have the components for video purpose. I have collected only 10 compounds, starting from artemisinin to resveratrol. So these all are the phytochemical constituents. So I just got the most popular phytoconstituents for this video. So we have 10 phytochemical constituents. So in this manner, you have to collect the name of your ligands. It can be either organic or inorganic, whatever it is. So just list it as in one row with a column header. So we'll use the code to retrieve the data of these phytoconstituents. For that, we have to open command prompt. So you can see this is my command prompt. Okay, what we have to do is we just have to open the codes. I'll share you the codes. So please download those codes. I'll just open my codes location. Yeah, it is here. So first we have Excel file. So we have to use Excel to Chem. That is it is a chemical formula and everything. It will be retrieved from using this code. So I'll just show you. Here we have to go to that location. Here mine was in desktop. Then codes. So this is the location of where my code is present. Okay, so just to open. So this is the location. So this is the location, and I have commanded the command prompt to go to this particular location where I have the codes. So I'll just ask Python to open the file XL. So just type the first two letters of the file and then press tab. It will automatically complete the sentence. So this is if it is present there. Okay, once you select that, please click enter. So let me tell you, once you click enter, the program will show you some interface. And if you do like this, so if it is not open for you, or else if it shows any error, please try to rectify it using Google or ChatGPT or whatever it is. You just need to install some of the dependencies for this, like RTKit or OpenBabel for upcoming course. Just install those using pip command, pip install, and the name of that module. Okay, so let's start with extracting. Here you have to select the Excel file where you have the list of the compounds. So just click, and mine was in multiple docking, and then test. This is my Excel file in which the compound names are present. I'm gonna just open it. It will ask whether the Excel file has a header or row or not. I'm just gonna check it. Yeah, it has a header of compound name. Okay, and then I will just select yes, it have a header. So we have to save output file as, it has to save output file as. I want to save it as in save. So data successfully saved to Excel, it is showed. So let me go and check whether it is saved properly or not. Yeah, it is there. Let's open it. Okay, sorry, I forgot to tell you guys you need an internet access for it. Let me connect with my internet, and then I will show you whether it is retrieving data from the PubChem or not. Okay guys, I have connected to my internet. Hope this will work right now. Just go to the command prompt again. It shows this is a connection error, this type of connection error here. Let's try the same code again. It will take some time. Yeah, you have to select the Excel file same as I do previous. Then yes, it have header. Then yeah, this is my file. No. Sorry, I select the file again. You have to select the output file. I just type PubChem. I'll show you why I type PubChem later. You'll get it on your own. Take time. Yeah, this processing. So it will take time if you have large compounds. Okay, it is completed. They are saved to Excel. Click OK, and then let's open the file. Multiple docking. Here it is. This is the downloaded file. Yeah, it has collected everything correctly. So let's cross verify anything. Just copy this and then paste it in the PubChem. So let's cross verify whether it has collected the data rightly. Let's search it. Yeah, it is diagenin. So this is the smiles for it. Okay, we have collected compounds correctly. Diagenin, yeah, it is. So we have collected the smiles, PCID, IUPAC name, molecular formula, molecular weight, and then other things through this code. So what for the next step, what we have to do is we'll select this and then open new Excel file, paste it here. Same way, select the smiles and then paste it in the next box. Okay, so we have a compound name and then its smiles. Okay, by using these smiles, we will collect the SDF structure from the PubChem using the codes I will show you. So just save this file. So I just want to save it in the multiple docking. In the name of smiles. Yeah, I saved it. So once you saved it, just close this, and then you can close this also. Yeah, we don't have anything to save. Okay, close this too. So this is okay. So we have smiles here, which I saved only the compound names and the smiles of the ligands. Let's close this and then go to my codes, downloaded codes. There it is. Yeah, this is good. Here you can see smiles to SDF. Smiles to SDF means using the smiles of the ligand, we will retrieve the SDF structure of the individual ligands. let's go to the course and then type ask file to run the code for smiles to SDF. So click enter. Select the Excel file with the smile and compound names. We have to select that file. Smiles. In the smiles, I only pasted the compound names and then it's smiles. Select this. Select the folder to save SDF file. You have to select the folder. I'll just make new folder of SDF. Okay. I'll select this folder. Does the file have header row? Yeah, it have a header row, compound name and then smiles. Yes. Column after smiles. Yeah, my smiles was in B column. Let's select B, and then my compound names will be on the A. Okay. Let's click OK. All compounds are converted and saved to SDF files. Okay, let's go and check whether it is converted. There is a SDF file. It is there. Let's open any one of the file. It is in the SDF format. Let's open Kumaravel. Hope you guys understand the video. If you have any doubts, you can reach me out. Yeah, it is the structure, SDF structure of the curcumin. This in the 3D structure. Yeah, we got it. Just close this and then close it. So next step, we have to convert SDF to PDB. Why? Because most of the docking, they use some will support rest of structure formats like Mol2 or PDB-QT. It doesn't matter. But for pirates, we have to convert it into PDB-QT. We can also import the PDB into pirates, but that will take a lot of time. So we will convert the PDB into PDB-QT by ourselves, and then we manually import the ligands. Let me show you. For the next step, what we have to do is SDF to PDB. We'll ask Python to run SD. Yeah, and the press tab, it will show the SDF to PDB. Enter. We have to select the folder containing SDF files. So this is the folder. Let me show you. In the SDF folder only, it has all the files for ligand, all the SDF files for the ligand. So open this and select folder to prepare. So save the prepare PDB. We have to select a folder. I'll just make a new folder named PDB, and then I will select this. So all files were converted to PDB and saved to that file location. So open that file location and post it again. Now we open file. Yeah, you can see in the PDB, it has converted into PDB format. So let's open question. So this is the questions molecule in the PDB format. Close this, and then we have to either if you are comfortable with PDB, you can go for PDB. But for pirates, according to me, if you convert into PDB-QT, you don't have to select the ligands individually. I will show you while I am explaining the docking procedures. Let's stick to this procedure right now. Next step, what we have to do is we have to hit file, and then we have to open PDB to PDB-QT, and then browse input file. Click input file, which is this is a PDB file, input file, and then output file. We have to make a new file. PDB-QT. So I will select this file, and then convert PDB to PDB-QT. It will start convert, and then it will show completed if the conversion has been completed. And then simply close this. We'll open the and close it. Okay. Let's open that folder. So here you can see it is in the PDB-QT format. So we have converted all the ligands into PDB-QT format, we have converted all the ligands into PDB-QT format, in which we will use it on the further steps. So these all are the contents for the part 1 video, and I will show you how we will do multiple docking on part 2. make sure you have downloaded my codes so that it will be useful for you. And then probably the next part will come right after this, I hope. So let's go and also download the PDB of the receptor, like RCSP. Just go and open RCSP. Also download the protein file for the docking purpose. So I'm going with the known receptor. Let's go for COX2, maybe COX2. So this is the receptor for COX2, and then COX2 mutant crystal receptor bound to the this one is good. Let's go for more common one. Let's take this one. COX with mefenamic acid. This is the structure of mefenamic acid bound to this human cyclooxygenase 2. So let's take this one and then open it. Download the legacy PDB format. So I'm gonna paste it in molecular docking file. So this is the receptor file here. I'm gonna save it here. Okay. In the next part, we will see about how to do molecular docking using Pyrex. Until then, bye.